Yes, students, welcome again. It's Mr. Hyper taking you through the fifth lesson of differential equations. And today we are going to look at inexact differential equations. Now, I first wrote some notes there so that we get highlights and hint on how these equations do be. Now, if we have an ordinary differential equation, wherever you see DE or DEs, it stands for differential equations. In this form, AXY dx plus BXY dy is equal to 0, where curl A curl Y is not equal to curl B curl X, then it is said to be inexact. It is supposed to be inexact. It's said to be inexact or non-exact. Yeah. Now, to solve the inexact ordinary differential equation, we need to first transform it to exact differential equation first. And that is done by multiplying the equation given by an integrating factor. We are going to see how we get an integrating factor. Then, after multiplying by an integrating factor, now you continue, get the main function, then you continue and do like we were doing. So the main thing here is to know how to get the integrating factor, and then we proceed. Yeah. So from this here, from this one here, we are going to look at basically, we say that the examples of these inexact ordinary differential equations are linear ordinary DEs. Ordinary, check the spelling. It is ORDINARY, ordinary. Yeah. So let's look at these linear ordinary differential equations. Yeah. When we say linear ordinary differential equations, as I told you, when you're dealing with this topic of differential equations, you need to be having the background of both differentiation and integration, yeah? Because we shall reach somewhere where you first need to apply integration by parts. You need to change a certain function into partial fractions and so on. So we need to be having the basics. You find somewhere you need to put time substitution, sign substitution, etc. You will reach somehow you need to solve a logarithmic function. So yeah, we need to have the basics. Yeah. So let's look at this linear ordinary differential equation. Now, a linear differential equation, a linear DE, is an equation expressed in the form expressed in the form of dy dx plus py is equals to q, where p and q are functions of x. What you need to know here, for you to excel in these numbers of differential equations, you need to note the forms in which they are written. So if you find a differential equation written in this form, now just know that it is inexact. You need to transform it to exact by finding the integrating factor, and then you multiply it through. So solve this kind of differential equation is quite difficult. However, we transform it into exact differential equation by multiplying through a factor that we call integrating factor. So now, if we suppose we let lambda be equal to integrating factor, yeah. Suppose lambda is equal to integrating factor. So it is this integrating factor that we shall multiply through. I'm sorry for that kind of quietness. if we suppose if we let lambda to be equal to the integrating factor, yeah, then if we multiply it through, meaning after getting this integrating factor, you have to multiply it through here. So if we multiply it through this equation, it means that we shall have lambda dy dx plus lambda py is equals to lambda q. If I let this one to be my first equation, yeah, now it would mean that d dx, yeah, of lambda y without a p of lambda y then is equal to lambda dy dx plus y d lambda dx. I call this one equation 2. Now, if you compare these equations 1 and 2, yeah, if you compare these equations 1 and 2, you're going to find that lambda py is equal to y d lambda dx, implying that lambda p, if you divide by y throughout, lambda p, I'm trying to derive an equation for you on how to get the value of lambda, the integrating factor. So lambda p is equal to d lambda dx, d lambda dx, implying that for this case, we shall have p dx if we separate the variables, p dx is equal to lambda, rather the lambda out of lambda. So if we integrate both sides, you have integral of p dx is equal to integral of the lambda over lambda. Here is separated variables. Okay, you can first multiply dx, then you separate variables by dividing by lambda. So here, when you integrate this, you're going to get the integral of p dx is equal to ln lambda. When you integrate d lambda over lambda, you get ln lambda. Now, we need what lambda is equal to. So lambda, we shall introduce e both sides. So lambda is equal to e, then the integral of p dx. Now, other things will follow when you have understood this. In case they give you an equation which is in the form dy dx plus py is equal to q, first get an integrating factor by integrating e to the power integral, by writing e integral to the of p dx, whereby p is the value that is always written here. Then what you get here, multiply it through, you will have converted the equation to exact differential equation. Let's look at examples and you see how easy this work is. Examples. I'll do you like 3 examples and then I give you an exercise. Examples, solve the differential equation dy dx plus 3 over x y is equal to 5x plus 4 given that y is equal to 3 when x is 1. Now, when you're given this equation, you really can see that it takes the form. If I'm to solve this, you need to first know that it needs to be compared with dy dx plus py is equals to q. Now, if you compare, you can see that where p is, here we have 3 over x. So you can say that on comparison, our p is 3 over x, while our q is, where q is here, we have 5x plus 4. Now, after doing this, we need to get the integrating factor first. So integrating factor is equal to E, integrating factor, we say that it is lambda, and we say that it is equal to E, then integral of P dx. Yeah, so it is going to be equal to E integral of P. Our P is 3 over x. So you write 3 out of x, then dx. Interesting. So this is equal to E. When you integrate 3 over x, you get 3 ln x. You get 3 ln x. Now, this ln is like log, so it acts like logarithm, meaning that if you have 3 ln x, the same as ln x cubed. So it is E ln x cubed. E and ln will cancel, and we shall have our integrating factor as x cubed. Good. Now, it is that x cubed that we multiply through this equation, so that our equation becomes exact. In other words, now, if we multiply the equation by integrating factor, it means that we shall have x cubed dy dx plus, if we multiply here x cubed, we shall have 3x squared. Yeah. If we multiply, here it was 3 out of x. So if you multiply x squared, if you multiply x cubed, sorry, you have 3 over x times x cubed. You have 3x squared y, so we shall say plus 3 over x y. So we shall have 3 x squared y is equal to, when we multiply here, it will be 5x power 4 plus 4x cubed. Now, you need to know what I've done. After getting this x cubed, I multiplied it through this equation, meaning here I multiplied x cubed, I multiplied x cubed. Yeah, I multiply, of course, when it is x cubed, of course, this x will reduce this by 1. So 3x squared, then y. Yeah, then like that. Now, we need to know the main function now. After now it is exact. Then what is the main function? The main function is the integral of that integrating factor with respect to y. So it is the integral of x cubed dy. X cubed dy, when you integrate this, you get x squared, rather x cubed y. Because if it was dx, it would be x power 4 over 4. But because it is dy, it means we are integrating x, but with respect to y. So it is going to be x cubed y. Now, this x cubed y, its derivative of the main function x cubed y should be equal to the right hand side, which is 5x power 4 plus 4x cubed. Then you integrate both sides. ddx, x cubed y dx should be equal to the integral of 5x to the power 4 plus 4x cubed dx. When you integrate the derivative, you get that very function, x cubed y, is equal to, when you integrate 5x power 4, you get 5x power 5 over 5, which will be x power 5, plus when you integrate 4x power 4, you get 4x power 4 over 4, which is x to the power 4, plus a constant of integration. And this is my final answer. That is my final answer. That is my final answer. So you need to master the steps. You need to master the steps very, very, very well. Very, very well. Yeah. Now from here, we are going to go to another example. Which other example is going to make us understand this very, very well. So example number 2. Example number 2. Find a general solution of the equation. The equation is dy dx plus y cot x is equals to 3 sin x cos x. Wow. Now, of course, your first step is to compare this equation. The first step is to compare this equation with what you expect to compare with dy dx plus py is equal to q. It means that where p is, there is cot x. And where q is, there is 3 sin x cos x. Can you first get the integrating factor lambda? Lambda is e, the integral of cot x, whereby here, of course, it is p dx, but p is already this, so cot x dx. How do we integrate cot is a question. So our lambda should be equal to e. When integrating cot x, you get ln sin x. Ln sin x. Someone may be like, hi Panga, we are dying. How do we come to this? To come to this, you need to be very, 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 very sure. So let me give you a hint. You know that a cot, yeah? So anyway, the integral of cot x is equal to the integral. To get cot, it is the same as cos x over sin x. dx. Yeah. Now here we are going to let u to be equal to sine x. So if u is sine x, what is du? Du is equal to, when you integrate, when you differentiate sine, you get cos. So cos x dx, meaning that dx, yeah, meaning that our dx is equal to du over cos x. Substitute here. So it implies that it will be the integral of cos x over sine x, which is u, times dx, which is du over cos x. These ones will cancel. Cos x and cos x will cancel. So when cos x is cancelled, we shall have our integral of du out of u. When you integrate du out of u, you get ln u, but your u is sine x, so it is equal to ln sine x, which is this. Now, it means that further, our lambda is going to be equal to, we have said E ln sin x, but ln sin x, E and ln will go, so we are going to have it as sin x. After getting it, multiply this integrating factor into this initial function. So it implies that we are going to have sin x dy dx plus, when you multiply sine here, yeah, when you multiply sine here, allow me to say that this is the same as y cos x. Someone is wondering there, how is cos x coming about? You need to know that cot is cos over sine. So sine cot is cot x is cos x over sin x. So if we multiply sin x again, sine will cancel with the sine, will remain with the cos. So when you multiply here the sine, it is going to be 3 sine, it was already sine here, so it will be sine squared x, then cos x. Then now come and tell me that your main function is what? My main function is the integral of what you got as your integrating factor, that was the sine x, then the dy. So it is going to be sine x y, implying that the derivative of the main function, which is sine x y, is going to be equal to the right-hand side, which right-hand side is 3 sine squared x cos x. Interesting. So after reaching here, now we shall integrate both sides. Of course, if we integrate, it will be d dx, yeah, then sine xy dx is equal to the integral, I can put the 3 outside being a constant, then integral of sine squared x cos x dx. Wow. Now reaching here, of course, we have to, of course, when you integrate a derivative, this is a derivative, you get that very function. So we shall have sine xy is equal to 3, yeah, 3. Of course, with respect to x, here you can apply different types of integrals. This is an even function. You can put any means of integrating it, but this is going to be equal to sine cubed x plus a constant of integration. Now, if we need y, our y will be equaling to sine cubed x over sine x plus c over sine x. Now it means that our y is sine cubed x over sine x. It will be sine squared x plus c over sine x is the same as like c times 1 over sine x. 1 over sine x is cosec x. So it will be c cosec x then plus, yeah, c cosec x, full stop. That is our final answer. That is our final answer. I see someone there smiling. It means that things are very, very, very easy. Number three. What if you're told to solve x squared dy dx plus y is equal to x squared e power 1 over x. Wow. Wow. This is very, 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 very interesting. Now, remember, for you here, you're expected to have dy dx only, but now it has begun with the x square. So what do? First divide by x squared throughout. So that here you create dy dx only. So you just say that dy dx is equal to dy dx plus y out of x squared is equal to, here if you divide by x squared, it will be e power 1 over x. So the first step here was to first divide through by x squared. Yeah. So after getting this, now we get our integrating factor lambda. Integrating factor lambda will be equal to the e, then the integral of 1 over x squared. Yeah. The p here, p is 1 over x squared because it's the coefficient of y. Yeah. So it is going to be equal to, of course, dx. It is going to be equal to e negative 1 over x. I guess you can get, because this x squared will move up, it will be x power negative 2. So if you differentiate, if you're integrating x power negative 2, yeah, it means you will increase the power by 1, you divide by the new power. When you increase the power by 1, it will be x to the power negative 1 over negative 1. So it is going to be negative x to the power negative 1, which is the same as negative 1 over x. Yeah. So, but this e must be there. So our integrating factor lambda is equal to e power negative 1 over x. Now, multiply this lambda throughout this equation. It would imply that you'll have you're going to have, you actually multiply into this equation after having divided. So we shall have e to the power negative 1 over x dy dx, yeah, plus when you multiply it here, you're going to have e power negative 1 over x, yeah, then times 1 over x squared, then y is equal to, when you multiply it this side, it will be e power 1 over x times e power negative, here it was power 1 over, okay, positive 1 over x. One is positive, then we're multiplying the one which is negative. Interesting. Now, our main function, will be equaling to the integral of our integrating factor e power negative 1 over x, then y. No, actually dy. I've rushed to the final answer. So it is going to be equal to, e power negative 1 over x, then y. Now, the derivative of the main function, dx of e power negative 1 over x, y, is equal to the right-hand side. Which right-hand side is it? When you simplify this, it's going to be e here. If we simplify this, it's going to be e negative 1 by laws of indices. Since you're multiplying numbers of the same base, you're going to add. This is e power 0, which is 1. Yeah. Then now we integrate both sides. So when you integrate, you have d dx e power negative 1 over x, y dx is equal to the integral of 1 dx. When you integrate the derivative, you get that very function. So it implies that e power negative 1 over x y is equals to, when you integrate one, you get x plus a constant of integration. That is it. 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 Yeah, so let's see what else I can do for you. I'm bringing the last question, then I give you two to do. I'll give you two questions to do. Doing my final question here, and my example 4. If time allows, I can do the fifth, because you really need to understand this work. Solve the equation. The equation is 1 plus x squared dy dx plus 2xy is equal to 1 plus x squared cos x. Given that, when they say given that, you have to think, given that y of 0 is 2. Yeah. So part of solution of this, the moment you don't see dy dx alone, you need to first divide this through. So what we shall do, we are given 1 plus x squared dy dx plus 2xy is equal to 1 plus x squared cos x. So it implies that if we divide it through, we shall have dy dx. It must be dy dx here, meaning you will divide, you divide, you divide. So it is plus 2xy over 1 plus x squared, because here we divided it, so it is no longer there, is equal to, when you divide here, it is the same, it will cancel. So we shall have cos x this side. Interesting, yeah. Now, after having gotten this, it means that our p is equal to coefficient of y. Touch on y and write the rest. 2x over 1 plus x squared. 2x over 1 plus x squared. Then our q is cos x. Wow. Implying that our integrating factor lambda is equal to e, the integral of p dx, which is going to be e, the integral p is 2x out of 1 plus x squared, then d dx. Now, your mind should be telling you, what is the effect of this? How do I integrate this? Yeah, to integrate this, I think we shall bring in now. Yeah, because I told you that when the derivative of the denominator gives the numerator, here now, if it was 1 over, you would have used the term substitution. But this is 1 plus x squared, meaning 1 plus x squared. When you differentiate this, the denominator, you get the numerator. So you put ln. So it is e ln 1 plus x squared. You use ln when the derivative of the denominator is equal to the numerator. When you differentiate x squared, you get 2x, which is up. Wow. So it implies that my integrating factor is going to be 1 plus x squared. Now, it is that integrating factor that we are going to multiply through now. So we shall multiply by the integrating factor lambda. So it implies that when you multiply by the integrating factor lambda, we shall have 1 plus x squared, yeah, dy by dx plus 2xy. Because if you multiply 1 plus xy, it will cancel. So we shall have plus 2xy only is equals to 1 plus x squared yeah, then cos x. This one is taking us far. What is the main function? Main function is equal to the integral of the factor, integrating factor, 1 plus x squared, then y. Actually, dy, sorry, I'm writing the final answer, dy, which is the same as 1 plus x squared, then y. Now, the derivative of this integrating factor, the dx of integrating factor, which is 1 plus, actually, of the derivative of the main function, should be equal to the right-hand side, 1 plus x squared cos x. Wow. So now integrate both sides. Dx 1 plus x squared y dx is going to be equal to integral 1 plus x squared cos x dx. When you integrate the derivative, you get that very function. So the main function y is equal to the integral 1 plus x squared cos x dx. Here, you can use two methods to integrate that. You can use partial fractions or you can use basic technique. I covered all that work when I was teaching integration. So I'm going to use the basic technique. I am going to use the basic technique to solve this, but here we shall use by parts, right? We shall first use it by parts. So 1 plus x squared y is going to be equal to, now here you must be knowing how to use integration by parts. Yeah, remember it is uv minus v minus the integral v du dx then dx. So it is going to be generally cos x. Members, take your time and execute this. Cos x dx plus the integral of x squared cos x dx. For use by parts and get me the final answer. So 1 plus x squared y is going to be equal to, when you integrate cos, you get sine. So sine x plus, now here we have to use by parts again, x squared cos x dx. Here, to use by parts, one can use the basic technique, which is very, very easy. Yeah. So I'm going to say for the integral of x squared cos x dx, I can use basic technique, whereby here I need sine, I need differentiate, and a function which can be easily integrated. I begin with the positive as a must. Easier function to be differentiated is x squared, and easier to be integrated is cos x. You change sign negative. When you differentiate x squared, you get 2x, and when you integrate cos, you get sin x positive. When you differentiate 2x, you get 2. When you integrate, you get negative cos x. When you integrate sign, you change negative 0. And when this one becomes 0, here the integral will be negative sine x. Then now we match. We have to match. Remember, I told you, you match with the signs. You match with the signs. Someone can use the by parts direct, but I see this one also easier for me to execute. Yeah, because it is allowed. So shall match x squared with the sine. You match 2x with this. You match 2 with that. 0 will keep there, implying that the integral of x squared cos x dx is going to be equal to, you bring it with its positive sign. So x squared sine x then this one will be positive because this is negative and it's going to negative. So plus 2x cos x, then this is positive coming to negative. So minus 2 sin x, yeah, plus a constant. But then we have to bring it to the other. So implying that, because this was on the right hand side, so we have to connect it and make it 1. So it would mean that 1 plus x squared y is going to be equal to sin x is going to be sin x, then plus what we have gotten, x squared sin x plus 2x cos x minus 2 sin x plus a constant c. But they gave us the initial conditions, meaning when they give us initial conditions, we have to eliminate the constant of integration. So they told us that y of 0 is 2, meaning that if y of 0 is 2, it means that x is 0 and y is 2. So it means that if we substitute for this, we shall have 1 plus 0, then y, which is 2, is going to be equaling to sin 0 plus x squared, which is 0, sin 0 plus 2 times 0 cos 0 minus 2 sin 0 plus a constant. This will get, this is 1, 2, the whole of this side is 0 plus c, so our c is 2. So after getting c as 2, substitute for that c is equal to 2 into the equation. So it is going to be 1 plus x squared y is equals to sin x. I'm putting into this plus x squared sin x, then plus x cos x, then minus 2 sin x plus 2. Yeah, so one can leave it here. One can leave it there. Or here one can, or one can say 1 plus x squared y is equal to sin x plus x squared sin x plus 2 into here is 1 plus x cos x here, then minus sin x, so that if we divide through by 1 plus x squared, it would be here, if we, this one here, we can put sin x out on this. So it will be sin x into 1 plus x squared also. So that when we divide, I've just simplified this further. So it would be y is equals to sin x, because I'm dividing by 1 plus x squared, which will cancel with that, then plus 2 over 1 plus x squared, then into 1 plus x cos x minus sin x. So that is what we have, and I'm giving you 2 numbers to do as exercise, then we see how best you can progress. So exercise, I want you to solve these equations. dy dx minus y tan x is equals to cos squared x. And another one, I want you to solve d dt d theta plus t cot theta is equals to 2 cos theta. and check if you'll come up with the answer. Let me add on, given t is 3 when theta is equal to 1/2 pi, and the answer you should come up with, t sine theta is equals to -1/2 cos 2 theta plus 5/2. Or it can be some different form if you can simplify. Then here the answer is supposed to be you have y cos x is equals to sin x minus 1/3. Y cos x is equals to sin x minus 1/3 sin cubed x plus a constant of integration. So try these and we see. That last section that we are left with is the homogeneous differential equations. Then we go to applications. Good time.